Hello and welcome again to another online streaming lesson. This is a lesson delivered by Mr. Sandwich, a qualified teacher, who's going to be taking you through a range of items to do with maths. What is the subject for today, Sammy?
Today we're looking at factorizing and expanding linear equations.
Wonderful. It's gone to your wonderful presentation visualizer before it's gone to you, buddy.
Sorry, say that again.
It's gone to your visualizer, not you.
Yep. Deja vu.
That visualizer is good though. It's much better than the one I bought. I bought one to try and do stuff like this, and but yeah, mine's just far too close.
No, we did this before, Nish. Please tell me that's made a difference.
Yeah, when you started, no, it's your screen again, buddy. So I would just go with your presentation and roll from there. Okay,
perfect. So we can all see my recap.
Yeah, presentation is absolutely fine.
Right, thank you. Right, well, good morning again, guys. Welcome back to mathematics. Hope you've all had a lovely weekend. We're going to start with recapping some stuff that we did on Friday, which was based on inequalities. And we also did some stuff on recurring fractions and surds, because if you remember on a Wednesday, we had loads to go through. So here's the recurring fractions. What we did when we recurred a fraction, or we had a recurring fraction, we found out what x was. So if 0.39 reoccurring was our number, then we had to convert it into a fraction. So we did that by finding out the 100th term, or multiplying it by 100 to give us 39.39, of course. And then to turn it into a whole number, we then subtracted one part. So we subtracted x from 100 and x to give us 99 parts. And of course, 39.39 reoccurring, subtracted by 0.39 reoccurring, gives us 39 as a whole number. And that's over 99. And then we can simplify it down to 13 over 33. If, of course, you were doing a number where you're working with the hundredths column and thousandths column that are reoccurring, then you would multiply by 1,000 and then subtract x, or you might subtract 10x. And then, of course, you'd have a number over 990 as opposed to 99. So I hope you found recurring fractions easier. And then we spoke about surds. Surds, of course, is just an irrational number. When you're square rooting a number or cube rooting a number, you are given a irrational number. And we spoke about how to simplify those questions. Then we moved on to number lines. And we did some demonstrations on what number line looks like when you're representing greater or less than. And of course, we've got the closed circle if it's equal to, and you've got the open circle if it's not equal to, and then you've just got to draw your number line. Finally, we had solving single and two-sided inequalities, and we looked to, first of all, get rid of the -1 by adding it to each side, and then you just divide 2 by each side. So in this example here, you'd have 6 divided by 2x to give us 3, and 14 divided by 2x to give us 7. Okay, so that was a little recap of inequalities, recurring fractions, and surds. There was one part that we didn't manage to finish on inequalities, and this is again something that you find on a higher paper, and it's based on shaded regions. So you are given an equation. You're given x equals -3 or x equals 2. Here's a couple of examples here for you. And if it says that x equals -3 and they want it greater, well, first of all, there is x equals -3, the blue line there. And if it said that x is greater, then you'd look to shade in all the area on your graph beyond -3, so above -3, greater than -3, I should say. And you'd literally create a rectangle or a square and use color or you shade in all that area. If it was less than -3, you can shade in this area. And the same with y equals 2. Here is the line y equals 2. If it's y is greater than 2, you would shade in the area that is greater than. So I'm going to just give you a quick demonstration. Here on my sheet, it says x is greater than or equal to 3. And we're just going to draw a line on the board. I'm just going to get out my trusty pencil case. Here's one I made earlier. And we've got -3, so that's on the x line. So we've got x -3, which is there. Draw a line on x -3, and then of course, then we're just going to shade in the area of x -3, because x is greater or equal to minus 3. So we could literally just shade in that area like that. Okay, and on your GCSEs, that would give you normally a 3-mark question, well, there or thereabouts. So it's a really good opportunity to get those extra marks. You just remember to know your x-axis and your y-axis and to shade in the area. Okay, so we are going to go back to our PowerPoint. That's inequalities completed from last week. Now today we're going to move on to factorizing and expanding. If we have time, we might look at triple brackets. Okay, but again, in terms of your GCSE grades, this can really range from a single bracket would be GCSE level 3, and then work your way up from there, right up until GCSE level 8, level 9 on the high paper. Okay, so this will cover a whole range of things today, but we'll start off with expanding. So as you can see on the screen, expanding is just to multiply each term within the bracket by the expression outside the bracket. So as you can see here, you've got 3 outside the bracket, and if you multiply that by the first terms within the bracket, which is 4x, 3 times 4x gives you the first part of your answer, which is 12x. Then we go back to the number outside the bracket, multiply it by the second term within the bracket, so it's plus 5. 3 times plus 5 is plus 15. Now, it's important, a lot of students I work with sometimes struggle to work out whether it's a plus sign or a minus sign or negative sign within the answer. Of course, all you do is when you multiply it by 5, you take the symbol with you. So when you're expanding a bracket, take the symbol with you here, and that will help you for when we go on to double brackets and even some factorization. So let's get some examples on the screen for you now. We've got some expanding here for you to do. I'm just going to zoom in a little bit. Lovely, jubbly. I'll tell you what, we'll come back to the top one in a second. 4 times y. So we're going to do 4 times y first, which gives obviously 4y. And then we're going to plus 2. 4 times plus 2 is, well, 4 times 2 is 8. And then we're taking the plus sign with us to make 4y plus 8. Okay, next one we're going to do 2 times 3w. Well, we know 2 times 3 is 6, and we take the w. And then it's 2 times 5 is 10, and we're going to take the subtraction sign with us as well. And don't forget the y. Here we've got 3 times 2 is 6y, and 3 times 1, of course, is 3. And we take the subtraction sign with us. Y times y is y squared. Of course, y times 3 is 3. And y times 5, we're going to have 5y. So it's plus, we take the plus sign with us as well. And then I said finally, we've got one at the top, but I thought we'll come back to that one. A times 3a is 3a squared. And then you've got 2 plus 2a squared c. Okay, so remember, you're just multiplying everything on the outside by everything on the inside. But you do the first term first, and then the second term, and then finally, we'll leave the best to last. We've got 2w times 3w squared. Again, if you want to break it up and just do the numbers first, that's okay. 2 times 3 is 6. W times w squared is w cubed. And then 2 times 5 is 10. And there's a w there as well. Let's take it with us. Okay, so that's single bracket. That's expanding single brackets. We'll be moving on shortly onto double brackets. We've got some questions over here for you. If we go back to the screen, the simple form expanding single brackets, just simply take the number from outside the bracket and multiply it by the first term and the second term. Factorization. So factorizing is, as it says on the screen, simply the reverse of expanding brackets. And there's a little demonstration here below for you to help you. If we know how to expand, then you might be able to work out how to factorize if it's just the opposite. The most important thing is taking out the common factors, so the highest common factor in particular. So don't just find a factor, it's got to be the highest common factor of that number. And when we go into factorizing quadratics, you're taking the highest common factor that does 2 jobs. It has to multiply, and those 2 numbers have to also be the sum of a number. And I'll explain in more detail what I mean by that shortly. So factorising is the reverse of expanding brackets, and you can simply do this by taking out any common factors which terms have. In this example here, you've got 20y plus 8p. So what are the highest common factors of 8 and 20? Well, we know that 4 goes into 8 and 4 goes into 20. So 4 would go on the outside. And then once we've done that, we've just got to work out what's 20 divided by 4. What's 20 divided by 4? That gives us 5y. And 8 divided by 4p gives us 2p. Okay, and of course there's one addition sign. We've got to take that with us. So let's have a look at some examples on my screen. 7 questions. So 2x and 6. What do we have in common here? What's the highest common factor here and here? The highest common factor would be 2. 2 goes on the outside. And then what did I multiply by 2 to get to 2x? Or what is 2x divided by 2? Of course, it's just x. Take the addition sign with us. And again, 6 divided by 2 gives us 3. So if we just check our answer, we're going to do the reverse, which is expand. So we do 2 times x to give us 2x. And 2 times plus 3 gives us plus 6. And as you can see, that's what we were given at the start. Okay, so remember, factorise and expanding just work hand in hand with each other, and it's just the reverse. Okay, 4m plus 12. So what's the highest common factor of 4m and 12? There's no other algebraic terms or any letters that we can use, but we can use the 4 and the 12. Highest common factor, of course, would just be 4. What do I times 4 by to get to 4m? Just m. And we're going to 12 divided by 4 to give us plus 3. And again, if we were to work backwards, we would get 4m plus 12. Slightly different here. You've got the highest common factor of 10 and 16, and you've got 2 letters on either side, but they're not the same, so it's not you haven't got common letters. But the highest common factor there would be 2, with 8y on the first term and 5n with the second term. Down here, you've got 5 being the common factor. 5 times 4p would give us 20p, and 5 times negative 3r to give us 15r. A few more here. 15b and 5t. Well, 5 is the highest common factor, so we'd have 3b subtract by just t on its own. Of course, 5 times negative t gives you negative 5t. And slightly different, this one, you've not been given a letter, an algebraic term. In the first one, it's just 9 plus 3x. The highest common factor of 9 and 3x, of course, is 3. What do we times 3 by to get to 9? 3 times 3, and then we're going to just add x. Okay, and that would give us 9 plus 3x. And then the final one, highest common factor of 12 and 16 is 4, with 3x on the inside and 4e on the outside. So that's factorisation in single form. So that is basic factorisation that you would see on a foundation paper. Remember, it's just the opposite of expanding. So find the highest common factor first, that goes on the outside of the bracket, and then just divide the number on the outside by the first term and the second term. Okay, now we're looking at expanding double brackets. Now this could be on a crossover of foundation and higher. So anything from a grade 5 upwards, probably looking up to grade 7. So 5, 6, 7, depending on the severity or difficultness of the difficulty of the question. Here's a couple of examples. Here's one example for you. And we use, in my school, I use the term FOIL, which you might be familiar with. We've got first, outside, inside, and last. Some find that helpful. We'll have a look at this one. So we've got x plus 4 and x plus 3. And what we have to do is, of course, multiply the first number by the first number in the second bracket, and then multiply the first number by the outer number in the second bracket, and then we multiply the inside number by the inside number of the first bracket, the second number of the inside number of the second bracket, and the second number by the last number in the second bracket. So once you get into a rhythm and you realise this is what I multiply by, then you'll get yourself an answer. Here we would have the answer x squared plus 3x plus 4x plus 12. And of course we can simplify that because we've got like terms. We've got plus 3x and positive 3x as well. So positive 3x and positive 3x. Sorry, positive 3x and positive 4x, which of course gives us positive 7x. So that's how you simplify that question. A couple of examples on the screen in a second. I can just flip there. And here we go. Let's have a look at these questions then. So we're going to multiply the first number of the second bracket, gives us x squared. And then we've got the first number by the last, or the outside number, I should say, of the second bracket, which gives us positive 9x. Then we've got positive 6 multiplied by x, which of course just gives us positive 6x. And then finally, positive 6 multiplied by positive 9, we know that that's positive 54. If you can get into good habits of simplifying your answer, like terms here are 9x and 6x, together gives us 15x. So we've got x squared, add 15x, add 54. Brilliant. Okay, the second question, so look at this one. We've got x and x together, we've got x squared, we've got x and minus 5, which gives us negative 5x. Then we've got minus 4 and x, which gives us negative 4x. And then finally, we've got negative 4 times negative 20. Remember, here we've got two negatives, so that will turn to addition for us. Now, again, if we simplified, negative 5, take away negative 4, would give us negative 9. So here, final one, and then we're going to move on to our final topics. I'm aware of time. If we started off with 2x and x to give us 2x squared, and then slightly different question here because you've got a number in front of the x at the start. 2x times 4 to give us 8x. And then we've got positive 1 times x to just give us positive x. And then finally, positive 1 times 4 to give us negative 4. Okay, brilliant. I'm going to just flip back to my screen and I'm going to give you a task to do later on today that involves, hopefully, it's optional and hopefully you are able to do the task. It's expanding and factorizing questions and expressions. So the final topic for today is factorizing quadratic equations. So again, this is something you'll see on the high paper. It's a quadratic expression can often be factorized into two brackets in the form of xa, x plus a, and x plus b. And it says here that a and b can be a positive, a negative, or a 0. Remember, it can be a 0. Some people don't always recognize that it can be a 0. And a and b can be found by using product and sum method. So remember, that's multiply and add method. And you've got an example here at the bottom of your screen. You've got x squared. So if it's x squared, we know that the first term in the first bracket is x, and the first term in the second bracket is x. That's the first rule. If we know it's x squared, then it must be x and x in each bracket. And then the rule really here is what two numbers, if you look at the 16 first, what two numbers multiply together to make 16? Well, of course, you could have 1 and 16. You could have 2 and 8, and you could have 4 and 4. But the rule is then we look at the sum method of the second question, and how do we make 8x? What two numbers come together to make the 8 that were also the common factors of 16? So we said 4 and 4, well, 4 and 4 also makes 8. So here then we've got 4 and 4, positive 4 and positive 4. Okay, so that's how we are to work out factorizing quadratic equations. And I'm just going to give you one example before we run out of time, and then we can recap it on Wednesday's lesson. If I go here, we will do, which one would we like to do first? We'll go with this one down here. We've got x squared, so we know that x, two brackets, x is going to go in here, x is going to go in there. What two numbers are factors of 20? So what two numbers multiply together to make 20? Well, I know 1 and 20, 2 and 10, also 4 and 5. And if we looked at it, which two numbers also add together to make 9? Well, it'll be 4 and 5. So 4 and 5 goes in there, and it's all positive. Put the positives in there. Nish, can you put me back onto the screen, please?
Hey, buddy, we'll do our best, but I'm quite sure it's going to show us your visualizer.
Ah, yes, you probably will. Well, on that note, guys, I'll leave you with this. There's a final. Sorry, it's let's change the colour there, but I just want to leave you with a final note. It says that a duck was given $9, a spider was given $36, and a bee was given $27. Have a go at this one. Based off that information, how much money would be given to a cat? There's just a little trick question for you. I hope you've enjoyed today's lesson, and I will make sure that you can see my face on Wednesday class lesson. Hope you enjoyed today, guys, and I'll see you soon.
Thank you so much, buddy. Have a great day. All right, Nish. Yes, I think it's funny when you can't see a human being for a long period of time. Just going through that. Sam's showing us his close-up of his. I don't even know what kind of like graph that's called, buddy. So I'm actually not going to embarrass myself by guessing. But yeah, we'll go back to humans, and then we'll pass over to you, Nish.
All right, cool. So here is the optional task for maths today. It is a link to a worksheet. There are 14 factorization questions on here, I believe. Some a bit more challenging than others. Please have a go. If you have missed out on anything today or on any previous sessions that we've done, they're all on Facebook and on YouTube. Link will be in the Facebook and YouTube descriptions as well. Yeah, next we have media.
Brilliant. Thank you so much, my dear. And yeah, we'll get that up and running. And I'll see you in 20 minutes.
Right, see you in a bit.